Yep. Yeah, okay. So today we're going to be doing something really fun. We're going to be calculating fractions in binary. Um, I just want to really double check that we're here. Like we're here, right? That this is on. Nobody's watching, but this is on. Okay. We have okay. Yep. Okay. I really don't want to do like a. Are we okay? Whatever. We're starting 1/1. So 1/1 is just one in binary. 1/2. Well, that's just one in the halves place. So that's 0.1. 1/3 is where it gets interesting. 1/3 is less than 1/4. And we know what 1/4 is. 1/4 is 0.01, just one in the fourths place. 1/4 is actually 1 in base 4 recurring for magical reasons, because it is 1 less than a power of the base. So it's rep 1 in quaternary. And similarly for 1/5, that is rep 0z, z being the highest possible digit in a base. It's rep 0z in quaternary. Now 1/6, that is just half of 1/3, so that is 0.0 rep 01. 1/7, that is 1 less than 8, so that is rep 0 1. Hold on, what? Sorry, rep 0 rep 1 in octal. 1/8 is just 0.001. 1/9 is rep 0z in octal. 1/10, that is, excuse me, 1/10 is rep 0. Oh, right, hold on. It's half of 1/5. So that's 0.0 rep 0z in quaternary. Now 1/11 is where things get interesting, because 11 doesn't work with any of these nice tricks. It's prime and it's not adjacent to. So anyway, we have to calculate it using the magic sequence, which we can do simply. So let's start by writing 11 in binary. So I'm using dots and pipes here because it's an easier notation to follow. I'm just double checking that are people actually watching this? 2 people are watching. I'm gonna trust that number is accurate. Okay. Right. So 11 in. So hold on. I'm gonna count this on my fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So that is 11 in binary. Let's put 1 more at the start just for good measure. What we do is we start at 1, then we double that, we get 2. Double again, we get 4, and then 8, and then we double again, but then this rolls over. So we have to subtract this, and we have to use binary subtraction. So that's pretty easy. We just start by, we borrow from here, and then we get rid of these, and that's, it's really, I got really fast at this, but okay. We're gonna keep going with this magic sequence, so we double again. This is not greater or equal. It's 1 less though, okay. So we double again. So we borrow, get rid of, and that. I say get rid of as just a term I tell to myself. Anyway, so then we double again. Subtract here, we borrow again, get rid of, double again. Oh, and that's larger. That's larger already. So we borrow, get rid of. Okay, yeah, and then we borrow, get rid of, and then we're back to 1. And now that we're back to 1, what we do is we're done. We've looped back. This sequence will loop infinitely. So now we go at each sum, and where it's increasing, we mark a 0. Where it's decreasing, we mark a 1. So that's decreasing, right? Yeah, of course it's decreasing. Decreasing, and then increasing, decreasing. And then this, if we put recurring, we have 0, 0, 0, 1, 0, 1, 1, 1, 0, 1. This is 1/11th in binary. We have successfully applied the... Hello? I just read the first chat message. Okay. We have 1/11th in binary calculated using the magic sequence. Now, let's keep going. We got 1/12th. 1/12th is same thing like we did for 1/6. It's 0.00 rep 01. 1/13th. I think we need magic sequence for this one, right? Do we? Yeah, we need magic sequence for this one because it's prime. Okay. So we add 2 to this. We get that number, and we can keep all of these. We just need to. So we're gonna be doing this for however long I want to. All right, here we go. So all right, so first, obviously we do the big borrow, get rid of these, and then we start doubling. That's 1 less. Do a big borrow, and then get rid of borrow. Shift, borrow, get rid of borrow. Borrow, borrow. Did I do that wrong? Oh yes, I did it wrong. We need to borrow here as well. Da da da. We keep going. This is we don't roll over yet. Okay, hold on. So now we. Oh, hold on. We borrow there, then we borrow here, get rid of. This is greater, so I think it's actually exactly 1 greater. So we borrow, get rid of. We have another magic sequence. Here we go. So decreasing, increasing, increasing. This is the hardest part for me, is figuring out when they're increasing or decreasing. I should be able to like parse this pretty easily. That's decreasing, obviously, right? Right? Wait, hold on. I just realized it's really easy to tell when we're decreasing because it's not a simple bit shift. That's what it is. So we're decreasing because its structure changes. That's increasing. It shouldn't have taken me that long to figure that out. Anyway, we can do a little redundancy check because there's a thing called Midy's theorem spelled like this. So not my theorem, but it's someone else named Midy, which is funny. I didn't know that was a real name, even like spelled differently. Anyway, so if you notice, so 0001, 00111, 011, you'll notice if I bring this over to a new line, the second half is a bit negation of the second half. So that's like a good redundancy check to have. I think I've actually noticed in some of the later ones, it's actually not quite the case. It's like only part of, like you remove some leading zeros, but it's still a thing. And now nobody is watching this. So I've successfully omitted everyone who's going to be watching this, but we're in this for the long haul. We're going to be calculating all these binary fractions, and I'm going to like it. No one else is going to. I thought it would be funny to stream this. So 1/14th, that is half of 1/7, so that is 0.0 rep 001. 1/15th. 1/15th. Oh, we have to calculate that. So we're off to the horses again, whatever that means. So yeah, we go here. This is a rollover. Yeah. And then there's no way it's that short. Hold on 1 second. 1 sec. Hold on, I need you to come back here so that the stream doesn't end prematurely. Okay, we're going real fast. What was it doing? Right, right, hold on, sorry for the long wait. I'm trying not to do that. So 15, we have 15 right here. right? Yes, 15. That's 1 less than 16. So that, yes. So then we just roll over. Oh, right. I forgot. I forgot this is 1 less than the power of 2. Sorry. So that means that we're just rep 1 in hexadecimal. Gosh, I so much apologize for this. So then we have 1/16. That's just 0.00010z in hexadecimal. 1/18. That is so that's half of 1/9. So rep. So 0.0 rep 000111 17 18 19. Oh, it looks like this. So this is 19 in binary. And what else? What do we do next? Right, we keep going. We keep going down the grind of that. So we do a big borrow and then get rid of these. Do bit shift, and then we subtract here as well because this overflows. So oops, that. We keep going. We do more bit shifts when it gets here. We now do that. I'm just like going so fast with this subtraction here. I was not doing this like this before. So then we borrow, get rid of borrow, and then we keep going. We do another bit shift. Oops. And then borrow, do a big borrow, do a bit shift, borrow, borrow. This is a rollover yet again. We borrow, borrow, get rid of. Here, we borrow, get rid of. We keep going like this. This is a long one. I think 19 was a long one. Who is watching this? Who would watch this? Oh, oops. I think I made a mistake. I don't think that's supposed to happen like that. Oopsie. I think I made a mistake here before last time. Okay, maybe we should like be a little more careful on my subtraction. Okay, guys. So here we do a big borrow and then get rid of. We bit shift, not greater than. We bit shift, it is greater than. So we do a borrow, get rid of. Oh, okay. That was just, we're back to 1. So, yes, we keep going. Okay, yes. So that's a decrease, increase, decrease, increase, decrease, decrease, increase, decrease, decrease. Okay. Yes, and this holds. So 1/19 in binary. After that quick little calculation is 0, and then it's the bit negation part 1111 00101. I'm just like constantly checking to see if anyone's still watching. It's so fascinating the fact that like anyone would watch this. Wow, I'm famous and on TV. Anyway, so it's 0.00 rep 001 because it's half of 1/10. We keep going. 1/21. We have to calculate this one ourselves. It's going to be another magic sequence one. Okay. Keep going. Let's grab our number again. Oops. We do our big subtraction again. We do a bunch of rep digits, then get rid of the overlaps. This goes over by 1, actually. And hold on. Yes. Okay. Yeah. This brings us back to 1. This was right. This was the weird one. So then it's decrease. So it's rep 000011. I don't know why it's like that. It's weird that like this is a weird edge case to Midy's theorem or something. Anyway, 1/22. All even numbers, so that's just 1/2 of 1/11th. So I will copy that. 0.0 rep that. Then we have 1/23. Okay, that's over here. Here we go. Okay, and then we do the big borrow, then get rid of the ones here. Oops. Alright, then this is greater than, so we borrow, and then we borrow again, get rid of that. Then this is also great, so we do a couple borrows. Yeah, that makes sense. And then this is greater than, so we borrow and borrow again and get rid of. Oh, oops. I think I made this mistake last time as well. I did this up to like what? Like not important. I did this up to like 32 yesterday. I think this is a mistake I made that time. I'm redoing it for the views though. I'm redoing all of this for the views. Nobody is watching me again. It's just always fun, like watching like little people coming in, realizing this isn't interesting, and then. But I find this interesting because I'm doing it. You don't find it interesting because you're not doing it. That's the key thing here. I'm streaming this because I thought it would be funny. So let's ignore that and keep going. Right. So I think this was the hard part. Okay. I'm gonna head back to all the way back to here. Like it's fine. I'm just gonna redo it. So we do big borrow, get rid of 2, and then that. Yeah. So that held up. You just want to like make sure everything I'm doing here is right. So simple borrows. Oops. And then we do that. Get rid of overlap. Oops. So we borrow. We do. Oops. My gosh. Why is it? I keep on selecting the line break. For here, we have to do a big borrow, and then get rid of that. So yeah, it all seems to hold. Okay, so then here, we borrow that. To subtract from here, we borrow that. To subtract from here, we borrow that. That seems to hold. So then, we do bit shifts. Okay, and then here, borrow, we get that. We borrow, we get that. What the heck happened? How? I don't think that should be possible, right? Huh? What? Okay, screw it. I'm gonna check what I did last time. What was the? Okay. What am I doing wrong? What am I doing wrong? Okay, hold on. I went all the way back here, and everything from there is sound. And then I get into this shortened infinite loop, which shouldn't be possible. Okay, this is greater than. We do that. Oh, I forgot to borrow from this. Okay. That was my fatal mistake, is I forgot, I skipped a digit. So, we're good now. We can keep going. I think this was a long one. This one's not greater than yet. 1, get rid of those. Heck. We've seen this before, haven't we? Oh my gosh. No. 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 Okay, let me try that again then. We borrow from here. There's just no way around it, is there? What did I... Hold on. Was it here? Was it here that led to it? Because, hold on. Because because yeah. So we borrow. We borrow. Oh, that was it, wasn't it? Hold on. What? Oh, wait, yeah. And then for here, we do a big borrow. Get rid of that. What? Huh? What? Okay, hold on. Okay, weird. I was not expecting to be second guessing my subtraction so much in here, but okay. Hold on. So I think it might have been at this line, the line that was supposed to lead to that one. So we do that. So we do that. This column we do that. This column we do a big borrow. That should lead directly there. It should not go through that. So I think we're still in this. I think that okay. So what we found was that this led to this. So we keep going like this. So from here, we do that borrow from this digit, or bit rather, and that brings us here. This is a place we've never been before. We're still free, and we're still in the wild. This is, again, we haven't seen this before. We keep going. And then, ba-ba-ba, next bit, ba-ba, ba-ba. I'm just, like, making sure we haven't seen every single thing that I go through, because if I'm just trying to get through this as fast as possible. Hold on. Yes, I almost made a mistake there. Yes. Heck, we've seen this before. What am I doing wrong? How am I so bad at subtraction? Why? Do I redo this? I think, okay, hold on. You know what? Yeah, this is cursed. I'm redoing this. Again, sorry. But nobody's watching this, so I should only be sorry to myself. This, as we see, does not roll over. So we go again. So we do that. For this bit, we get rid of. We do a big borrow. And then we get rid of that. So next up, we do this. That rolls over. So we do that. Next bit, we do a little borrow like that. And then from here, we... Hold on, there's already a bit there. So we just get rid of. This bit we get rid of. Then we're down a little chain of that. This rolls over. So we do a big borrow, get rid of these two. And oh my gosh. I can't believe I went on this whole wild goose chase. It ends right there. Okay. So easy now, decreasing, increasing, decreasing, decreasing, increasing, increasing, decreasing. Oh my gosh, it shouldn't have gone like that. So 0 0, rep 0 0 0 0 1 0 1 1 0 0 1. Does that? How does this follow Midy's theorem? I think when I got this result, I was so confused because like it look like hold on, like, but where do we break it so that it's such a weird one to me. Like hold on, like okay, it's a little different from that one. I was like, what? This looks exactly the same. I'm not gonna check with my other ones. If there's a mistake in it, that's just how the game works. Okay, we keep going. 1/24. That's if we go. Okay, we go up here to 1/12. That's 0 0 0. Hold on, I should post this in my Discord server that you're not allowed to join. I should go to stream settings, and where's the link? I just want to stream to the. I just want to link to the stream. Do I just? Yeah, I can copy the URL there. Let me open up Discord. I'm gonna hope that it's not gonna show up in the stream. I've been streaming for 24 minutes. 24 minutes, and we're at. That's like 1 per minute, but it's gonna slow down because there was the way averages work, you know. I'm gonna... Okay, it's not showing this. It's fine. You guys can't see what I'm doing. That's just how streaming works. I'm not a very experienced streamer, as you can see. So, yeah, now I'm posting that in my server, that you're not allowed to join. I'm gonna reiterate, you're not allowed to join this server. Just, yeah, you know, you gotta get the word out. Hold on. Live stream. There we go. I'm going to close Discord now because I don't need it open right now. This is my one object of focus right now, is doing binary fractions. Anyway, so yeah, 1/24th, that's 1/2, 1/12. And let's wrap 0, 1 with some zeros because it's, yes. So next we have 1/25th. Again, we got to use the magic sequence for this one. We got to use everyone's favorite tool, the magic sequence. So what we do, okay, hold on. I need to add 2 to this. Right, so that is 25 in binary. We again go back here, put it at the end, and we keep going with the whole thing we've been doing. Yeah, okay, hold on. We don't duplicate it yet. So we do that, get rid of those, and we just go for it. That's what we call a rollover. So we borrow, get rid of, in this case, like, a modulo calculation is straight up just division. So it's straight up just a single subtraction, because you only know you're only gonna roll over at most once. So now what we do what I like to call a big borrow, and then we get rid of that, and that doesn't go over, obviously. Yes. Okay. So next we do that again. Borrow, get rid of. This one stays. We keep going. We shift it. We do that. Get rid of, and we borrow, and we. Okay. Yeah. Here this rolls over again, obviously. And then for this one, we do a little mini borrow, get rid of, and then we borrow, and we what did I do wrong there? Oh, I think okay, yeah, sorry. We subtracted too soon. Yes. Here we do a borrow like that and a borrow like that and get rid of. Now we do another bit shift. And we need another bit shift as well. Borrow, get rid of, and we shift it, and then we borrow, get rid of, shift. This is actually only over by 1. And you know what that means? That means that this is our 1 and we're done. So, we just borrow like that and get rid of these. Magic sequence, let's figure out what it is. So that's 1, 0, 1. Yeah, and then we're ascending for a little bit. And then until we hit here when it's descending, 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 ascending, descending, ascending, descending, descending, descending. Okay. This is our honkin' little fraction. So we got 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, 0, 1, 1, 1. Let's double check this with Midy's theorem. Yep, it all lines up. Those are bit negations. We've got 1/25th. Next we got 1/26. 1/26 is an even number. It's twice 13, so it's 0.0 rep whatever 13 is, which is this funky little thing right here. I'm just going to copy it because I don't want to get any copying error in. Look at that. We've got the first 26 already. Hello, one person still watching, unless you're not watching because the stream's maybe delayed a bit. I just want to make sure you're still keeping you company. Is there anything else you could be doing? All right, so it's 27. Again, we have to do the magic sequence. We add to this. And we go ahead and plop that at the end here. And we bit shift this. And we do a big borrow, get rid of, next. So we just keep doing that. And now here we borrow a couple times. This is how fast subtraction is in binary, like truly. And then borrow. Is that how that works? Yeah. Yeah, we just borrow in that direction. We borrow, then we borrow, and that's how it works. Okay, we go again. We borrow. We do a slightly larger borrow, and then yes, and then we go when we get here. It goes like that. Oops. It always goes a little haywire, and I don't even eat hay because I'm not a horse or equine otherwise. I was like second guessing, like, is that how that works? You just like bit shift it back. Okay, I did like 2 steps there in one, so yeah, I'm doing like what you might call advanced and fast. What else was I doing? Right, okay, yeah. So we got another one, we bit shift it, not roll over yet. So we bit shift again. Next we keep doing that. Do borrow, get rid of. Have we seen this number before? I just like want to make sure. Oops. Am I still streaming the same window? I hope I didn't leak my homework. I don't think I did. I might have been going a little fast. Let's back up a little bit. This shouldn't have led to a loop. Right, so we keep going. This rolls over. We do that, and then here. Hold on. We do that, we do this. We get rid of. Yes, we are here. Have we seen this before? No, we haven't. Just like triple checking. So here we simple, it's a simple, that, which doesn't happen a lot. And then we heck. Right, yes, we have to bit shift it first, of course. Right, so we borrow it like that. Oh, yeah, the first one is always a borrow, isn't it? Interesting. Right, that's why that doesn't happen very often, because it's not supposed to happen. Yeah, so we get here. And then next we do that. Heck, I forgot. I keep on. Okay. We're ready now because we rolled over. So that's a simple. Oh, and we're at 1. Okay. That's what happened. We're at 1. I just like missed it. Yeah. Okay. Yeah. That follows, right? Yep. Makes sense. Okay. Now we're really done. That ends in a 1. And yeah, let's just go. That's descending, ascending. Then we descend, we ascend, we descend, we descend, we descend, and we descend, and we ascend, and we wait, holy heck. No, wait, hold on. That's not true, isn't it? Right. Never mind. I was just gonna like hold on. Like these kind of look like the final bits of all these, right? Like you know how they see how they kind of match up like that. Suspect. Right. Yeah. That's gotta be like this has gotta be like a special case, right? Like there's no way that's true in the general case. Anyway, we're at 32 minutes. We're going at pretty slow. Yeah, you're the only one watching the stream because I actually don't have a very active subscriber base. Like, you know, like I don't know. It's like, you know, like I don't know. I feel like I have a lot of dead subscribers. You know, not like dead, but like anyway. Enough of that YouTube stuff. We're in math territory. We got to do mathematics today. How mathematical can we get today? Well, today is math day, only for me, and I'm only doing fractions binary, which is only a little math. Anyway, that's 4, and then 1 0 0 1 0 1 1 1 1 0 1 1 0 1. All right, next we got another even number. Even numbers are half of the numbers, and they're easy because you get to use previous work. So 28. What's 28 divided by 2? We can do. Well, no, I'm not doing long division in binary. It's easy, but I don't feel like doing it. This is I can easily do this mentally in decimal. That's 14, obviously. So 14. It's yeah. So it's 0 rep 0 0 1. That is That is 1/28th. Next up, we have 1/29th. Again, we gotta do it ourselves. We're approaching another power of 2. So 1/29th, that's 27 plus 2. I want to double check. Like, this is right? Hold on. I'm going to put this number on my fingers that you can't see. Hey, Vsauce. Where are your fingers? That's not what Michael sounds like. Michael from Vsauce makes a different voice. So we got one. Hold on. Okay. I'm going to do this by counting up to 32. So 29, 30, 31. Oh my gosh. This number is wrong. Wait, hold on. We're on 27. Bleh. So 28, 29, 30, 31, 32. Yes, this is correct. We add 2 to this number. We get 29. I just wanted to make sure that... Alright. Next up, we got that, and then we get rid of... and then we, we just keep shifting it. We just can't stop shifting. Anyway, now that we're here, we do a big borrow. This one stays, we get rid of, and we borrow again. Now, another bit shift, borrow, get rid of, borrow, get rid of. Shift. This one doesn't go over yet. Wait, oh. Wait, oh my gosh. Yeah, it is the final bit, actually. It is the final bit. Hold on. I'm going to finish this first. Because it always starts in a borrow, and then always puts a 1 here. So if you want you can actually just read off the final bits of all of it. That is, I'm so happy I found that myself. Like, so often I'm just told things. I like finding things for it's a rare occasion when I find things for myself, but that's so nice. I know I find simple things by myself, because I'm still learning, but you know. Anyway. Yeah, so let's keep going. You know, bit shift, another carry, not carry, opposite of a carry. That's called a borrow. The opposite. That's a fun fact. The opposite of a carry is a borrow. You know this from elementary school mathematics. I'm calling it mathematics because it's a more sophisticated term that has much more sophisticationes associated with it. And you know, we're in a really sophisticated day right here because we're calculating so many fractions in binary. Have we seen this number before? We haven't. Okay, good. Just double checking. Now we do another bit shift. I can actually just figure this out. First part out in my head is like that. I'm getting. Oh my gosh, my fingers just do this automatically at this point. It's scary. Why it doesn't roll over there? We have to go more. One more step, and then we. Look at that. I'm doing 2 steps at once. It's crazy. Can you do 2 steps at once when you're subtracting? I don't know if that's a normal thing, because I don't know how to do subtraction in decimal. I only know how to do it in binary. And you know, due to Poe's law, you can't tell if I'm being truthful about that or not. But here's the thing. I don't care. Anyway, so that brings us back to 1. Yep. So now we do the faster amount. I'm like, instead of looking at the whole number, you just look at the last bit, and then you look at the ones where there's a 1, and that's where your 1s are. And oh my gosh, math is beautiful, especially if you're looking at it through binary, because you know, bases and number representations are just like a lens we use to look at math through. You know, I think binary is a better lens than decimal. In fact, and better lens than any other base. It's wonderful. I love binary. Thank you, The Best Way to Count, for being the best video I know of on the internet to me. Because everyone has their own opinions. And the best video to me can be the best video to you. But anyway, yeah, if you like binary, or if you don't like binary, and want to be convinced of liking binary, then go check out The Best Way to Count. If you search for it on YouTube, you'll find it. It's by the channel The Best Way to Count. That's right, they made a whole channel for this video. So that's rep 401 000 11 01 00 11 110 111 001 011. All right, let me just double check that with the parity check or the redundancy check or whatever you want to call it. Not a parity check, but you know what I mean. All right, that's 29. That's a big honkin' fraction right there. That's the longest fraction we've calculated today. So next we got 30. What's 30? 30 is actually twice 15. So 1/30th is half 15, half a 15th, which is this. So we can put that in here. That's 1/30th. Now we get our funny tricks again because we're approaching a power of 2. 1/31th is 0.000. It's that because this is 1 in base 32. Next we have 32. That's, hold on, this is rep that. That's 1/32nd. And then we have 1/33th, and 1/33th is rep 0s, 5 zeros, 5 ones. So rep 0z and base 32. What did you say? Hello, 1 ton. Who are you? Who are you? What did you say? I can't see you because it's covered up by the activate Windows watermark. Can I zoom in my browser? Baller. That's a good message. I'm glad you said that, 1 ton. I find your message very insightful. Like, what is a baller? Is that a BFDI thing? I don't watch BFDI. I watch binary. So 1/34th, that is 0.0 rep 1. Hold on. What's half of 1/34th? You know, one way you can figure out is by division. So what's 1/34? What's 34 in binary? Well, it's if you take a 1. Okay, it's like 1. Okay, sorry, we're dividing it by 2, which looks like that. So divided by, hold on, do I have that on my? I don't. Okay. So it's 32. No, that's 16. So that's 32. And then there's another thing in the 2 space. So that's right. You thought this was just calculating binary fractions. We're also doing long division in binary. So, this is right? Hold on. This that's 32, right? Sorry, 34. Because we have 1 in the 32's place. Because this is the 16th place. I'm just like redundancy checking myself over and over again. Okay, yes. So this is it. This is our math problem. And we're gonna do it. Let's even do the funny fancy thing like that. Let's even like put it. Oh, right. Let's forget about that. Yes. That is actually distracting. It looks like a root. Let's not do that. So yes. Anyway, let's do the actual calculation. So we find the largest part of the dividend greater than or equal to the divisor, and then we write a digit in the answer. And then, yes. So then we subtract, and we get 0. Pull down more bits. Okay. Pull down another bit. I'm just now realizing, since we're dividing by 2, this can just be done with a bit shift. But I'm not going to do that. I'm going to do this the long way, because I want to show you guys how cool long division is. So now here it still doesn't go in. Here it does go in. And in fact, it goes in exactly. So we have remainder 0. I could have done that in my head, man. Like, this is a very... Okay, the thing is just 2 is very easy to divide by. It's like dividing by 10 in decimal. Except you're in binary, so it's dividing by 2. And dividing by 2 is such a useful thing. This is one of the reasons I love binary. It's like, it makes... Like, Anyway, so what's this number? We read this out. This is 16 plus 1. So it's 17. 34 is 17 times 2. I did not need to do the long division there. I thought it'd be funny, you know? That's the whole purpose of the stream, is because I thought it would be mildly funny. Not that funny, but mildly funny. So that's 34. 1/35th. Now we actually have to go back to doing magic sequences. So let's rewrite our number again. So we established that this is 34. So that's 35. And in fact, we're going to need an extra buffer bit at the beginning of all of these. So let's put one there. And in fact, our initial sequence, we're going to have to make it longer to accommodate. And we begin again with more magic sequences. 36 is where I got up to yesterday. So at that point, we're just going to keep going. It is currently... How long have I been going at this? It's been like 45 minutes. That's pretty good. I do want to get this done. I'll go on for as long as I want to. The moment when I stop wanting to do this is the moment when I stop streaming. Like, ideally, we go on for like 4 hours or something. Like, if I feel up to it, I might not feel up to that. Okay, we keep that. Oh, then we just do that. So that's our subtraction done. Let's do another one. Let's do a borrow. Let's do a borrow. Let's get rid of that. Let's keep going up and up and up and up. So up's full. And then we do more stuff. The subtraction is just second nature to me at this point. All right, so that's that. And then we find our fraction pulled out. We get that, which looks... Why? Hold on. I need to, like, double check with this one. There's no way... Hold on. Let me... What was it called again? I called it binaryfractions.txt. I'm just going to open that, double check what... What did I get last time? That is exactly what I got last time. All right, this is the last magic sequence that I calculated last time. So it's just rep 0, 0, 0, 0, 0, 1, 1, 1, 0, 1, 0, 1. Again, no idea how Midy's theorem applies there. Again, I said this before, Midy's theorem is spelled like that. It's not a theorem that I made. It's just someone else whose name is pronounced Midy. And their name is spelled differently than mine. So that's the main reason you can tell the difference is because their name is spelled differently from mine. The other main difference for me is that they're more qualified in mathematics or something. Or I don't know. I actually don't know anything about the creator of Midy's theorem. I just know that they have a name that is pronounced the same as mine. Anyway, 1/36th. This one I'm going to do in my head. No, I'm not going to. This was 17, so this is 18. It's 2 times 18. Right? I feel like I need... The thing is, I'm writing these in decimals, so I have to, like, think through the math in decimal, which I'm bad at. I'm only good at math in binary. I'm only good at doing, like, at calculating arithmetic in binary, on paper. Or in this case, on digital stuff. We got 3 concurrent viewers. That's, like, a record for us. Hold on, let me look at our analytics. Wow. That's so much better than we had earlier. Anyway, so, it's 1/18th, right? Like, hold on, I need to, like, double check myself. Okay, so 8 plus 8, yes, 8 plus 8 is 16. That's all I needed to know. We add another 0 there. Boom. Oops. I'm not going to burst the Sublime Text license because I shouldn't admit that. I might. I kind of want to. The only problem is I don't have money. I do have money. I'm just scared to use it. So I'm not going to talk about that any further. So 1/37th. We do this again. Right, we add 2 because the last one we did with 35, and we keep going. Let's do another one. Yes. So, actually, I'll just start with the first borrow, because this stuff is always going to start with a borrow. Then we just get rid of the overlapping digits. It's the easiest one. Even these are still super easy. Like, look at this. Look at how much butter is added to the equation. Like, look at this. My fingers are doing this by themselves. Like, yeah, we do that, and then we do a big borrow, and then we delete that. Like, look at this. Can you do this in decimal? Serious question. If you can do math in decimal, if you can do subtraction in decimal, does it go this fast? Like, I know that these are represented with, like, way less stuff. Like, these are, like, 2-digit numbers. But, like, you know... Like, look at the absolute speed and fidelity that I am doing this with. Phi right there. Okay, hold on. That was actually, I said fidelity. That was me saying the Greek letter phi and, sorry, hyphen, delity. The hyphen here is important. It is distinct from an n dash, or perhaps even an m dash. It is a hyphen. This detail will be very important. So yeah, we keep going. We do another bit shift. Oh yeah, and this rolls over, so we do that. Get rid of. We got 3 right here, and then this is gonna be a long string of magic sequences. Are so fun to calculate. You just like do all that. Before I was doing this in like decimal or whatever, but I'm now realizing it's so fun to do in binary. You know, that's part of the reason I decided to do this stream. I just love doing this. It's such a like enjoyable. I did not roll over there. I shouldn't have done that. We keep going. Hold on. Not to be confused with I said, what I said there was, we. I didn't say a different word. Okay. That's correct. Okay. We keep going. Okay. So we do that and that. We gotta keep cranking these out. Like this is the main event right here. We can't get too many distractions along our way. Distractions will only slow us down. I think we are greater. Oh my gosh, hold on. We did it. We reached 1. I'm just gonna rewrite 1 here because I can recognize that's 1. Okay, we're at new territory for me. I only went up to 36 last night. 37 is new territory, man. So here we go. 1 1 0 1 1 1 1 1 0 0 1 0 0 0 1 0 1 0 0 1 1. And then actually, what we can do here is we can select these. We can do a little funny trick. And then we can make our cursor long. Boom. I just saved myself like so long that it would have taken to like type all those bits up. Especially with the fractions getting longer. It's like harder to fit them in vertically. So that'll be an especially useful trick. 1/38. What's 38 divided by 2? I considered doing the joke of I'm gonna use my calculator for this, but no, this is a no calculator zone right here. We're not allowed to use calculators to calculate this. This is all about by hand calculation. So what is 38 twice? But we did that for 36. It was 18. After 18 is 19. That makes sense because 9 plus 9 is 18. We're cranking these out. Is 0.0 rep 1/19. We keep going. 1/39. 1/39. So we add 2 to our number here, and we get rid of all this junk again. We add 2 to our number here, which looks like that. This is 39 in binary. We now... oh, right, hold on. Yeah, this is big borrow zone, and then we get rid of the overlap. Skip to digit, we gotta borrow from there, then we borrow from here. And we didn't roll over. Why is this the biggest problem where I do things that before I'm supposed to? I'm just too eager to do that subtraction, man. I'm too eager. I'm like eagle. I'm eager eagle. Eager eagle. No comment. Anyway, I do have a comment though. Bananas. Bababnas even. Hold on, that looks familiar. That's different, right? Okay, hold on. We gotta do the funny process again. Yeah, that's shorter. That's okay. Rep that. Yeah, that's what's 1 bit shorter. Bleh. Yeah. All right, we keep going. We go 1/40th. 1/40th, that's easy to figure out because that's just 1/20th divided by 2, right? Yes, 1/20th over 2. So that's 0 point, and then sorry, that's 0.0, then the whole thing for 1/20th. We keep going. I might go up to like at least 1/64th here. I'm thinking at the highest I'll go up to 1/256th, but 64 might be a good place. No, no. I don't know what I want to do here. So let's do 41. I've got to keep cranking these out, man. I've got to keep cranking these out. So 41, that's that in binary. We do our big borrow first. Get rid of the overlapping bits. And then that's right? Right? Like we just borrow and then yeah, bleh. What am I doing? I need to stop second guessing myself. It'll just work out. Alright, that's 1 fewer, so we... Oh, it's gonna be a big borrow! Big borrow! Yay! I love big borrows! Hey! That's the voice from the Lego commercial where they have build the helicopter. I hope you like my impressions. My impressions aren't very good, but I enjoy making them. I think you should too. I think you should enjoy making my impressions. Hold on. Yes, okay. I just like wanted to like double check that I wasn't skipping that bit in the previous round. So yes, we borrow there. We do another borrow. Eliminate that. Keep going. We do a bit shift. We do a borrow. We do a borrow. We get rid of. We do a bit shift. We do a borrow. Not yet though, because we didn't roll over. We didn't roll over yet either here, so we bit shift again. And we do a big borrow. And we do another borrow, and we get rid of. And then here, we do a borrow. We get rid of. We do a bit shift. We do a borrow, and we get rid of. And we're at 1. We are at 1 once again. Now. Hello, one ton. I'm just go banana. That impression was. Oh yeah, I'm not checking chat very often. I have it in another screen that I just like go off to every once in a while when on my whims. Yeah. So what else was I doing? 1 1 0 0 0 1 1 1 1 1 0 0 1 1 1. What was I doing? 0 0 0. Oh wait, hold on. Wait, no, I don't have to type that out anymore. I've got my little trick. I've got my little sleeve trick. They call it a sleeve trick because it is up my sleeve. My sleeve is very long and contains many things, but it's not long enough to contain the universe, as the universe is potentially infinitely large. And even if it weren't infinitely large, the observable universe is already too big to fit in my sleeve. There are limits to my sleeve, and that must be acknowledged. 1/42th is twice 1/21th. 0.0 rep 0.00011. Still don't know why it looks like that. Looks like a violation of Midy's theorem, but what do I know about Midy's theorem? I didn't even read the Wikipedia page for it. I just know about things like, look at 1/11th here. You know, see how it's the bit negation? The bit negation like that? That's all I know about Midy's theorem, because I watched a YouTube video. Whatever. Anyway, yeah, we're continuing. We're cranking them out. No more talking. We are doing 1/43th now. We are doing that, and I'm even gonna do this first step like this. Like that looks terrible. I need to do it this way, because if I do it any other way, there is potential that it could go wrong. This is. Yep, and then we don't roll over yet, so we do another bit shifts, and we we do a borrow, we get rid of, we do a borrow, we do a we do a borrow, we do a bit shift, we do a borrow. I just realized I always type the 0 there and then immediately delete it. I always right. So anyway, we do a borrow, we do a big borrow, we get rid of, we do that, and we do this, we do a borrow, we do a borrow, we do a borrow, and then wait, do a bit. I am not gonna be able to get out of that habit. It's just not gonna happen. We do that. Hold on. Yes, we do that, and then we do that. We're doing borrowing here. Borrowing in binary. One might even call it borrownary. What was I doing? Right. I do a borrow, and I do a I'm not gonna be able to stop thinking about how I do that. That's hold on. No, I don't do it yet. It just doesn't roll over. How do I keep on not noticing? This rolls over though. So we do a borrow, and we do a get rid of, and then we're at 3 again. It's always nice when you hit 3. It's just like this little quaint little module that we move around, you know? Just a quaint little module is what it is. And this rolls over. So this rolled over and does tricks. I know what tricks is, and tricks are for kids. So, and I'm not a kid, so I will not comment any further. The Tricks Council doesn't let me. Hold on. Yeah. We do a borrow, and then we do a borrow, and then it's always nice when it gets like a bunch of ones. So then we do that, and then what do we do next? Right, and then we just get rid of, right? This one's taking a while. Have we come across this number before? No. Okay, good. So we do a bit shift. Not rolled over yet. Do a bit shift. We borrow, and then that looks like it works. One of these days we're gonna hit 1. Like, I'm just like, we're not messing up here. We're doing it exactly right. And that rolls over. So we do borrowing. Oh, we're at 3 again. Did I mess up? How did I mess up? Okay, I do know we haven't hit this before. So yeah, it means that my calculation is wrong. I did my calculation wrong. So yes, this rolls over. So then we do that, and that. Oh my gosh. Oh my heck. Sorry, I shouldn't say heck. That's a bad word. Bad words have bad influences on people. No. No, this means that the thing I got to before that. Oh my gosh. Hold on. Yeah. Hold on. Let me get rid of that. The thing. Okay. Now I need to double check. Did this get me to 3? Does this actually get you to 3? It doesn't. It gets you to 1. And I've been on this whole trail of stuff after 1 that's not even there. Because this is all there is to the fraction. Quaint example of Midy's theorem. I should, like, at this point, I should just look up the details of Midy's theorem. Not going to do it on stream, though, because, you know, that should be dealt with in the privacy of my own learning, of my own Wikipedia reading or whatever I do. That'll probably be a good place to start. Anyway, we're at 43. Next up, fraction 1/44. What's 1/44 twice? It's 1/22. 1/22 is this. And if you have 22, then I think you should go see a dentist, because that's not normal. Sorry, that's not even that funny. Next, yeah, so go 1/45. 45. What's that number? That number is Okay, right. How do we write in binary? We add 2 to our existing number. And then we... Yes, okay. Here we go. We start with our borrow. Get rid of these guys. We do a bit of shifts. You know all the drill. Unless you're just stuck tuning in which case... Okay. You can tune in if you want to. If you don't want to tune in, then don't. I think you shouldn't do things that harm you. And if watching this stream causes a lot of harm to... What am I saying? This isn't even real. What am I doing? Oh, this already rolls over, of course. So that's that. Get rid of easy stuff. Oh, yeah, and then that is one of those. Hold on. This doesn't roll over. Yeah, hold on. It does that, and then we do... Hold on. What does that look like? Am I doing that right? Yeah, I do that. I do a borrow. I do another borrow. And I get rid of those ones. That makes sense. Oh, and we hit 1 already. Nice. That's 1. I can just tell that's 1. It's okay for me to just write 1 there. That's 1, 1, 0, 1, 1, 0, 1. We've got another weird 1. Yeah, that looks right. Yeah, it's just like the similarity to the other one is just like it's tripping me up a little bit. Anyway, 146. We gotta keep the energy going. We gotta keep all the energy going. How long am I going for? I've been going for 1 whole hour. I've been going for 1 whole hour. This is the 1 hour anniversary of this stream. All right, so 46. 46. What we doing? 46. That okay. So 23. Yes, we're going 23. So that means it's twice that. So 0.0 rep 23 147th. We add 2 to our number. We calculate another magic sequence. And it looks like wow, that's a lot of interesting. Because we've got a lot of high bits, you know. That doesn't roll over. It doesn't roll over until we remove that. So we borrow, get rid of, big borrow, get rid of, get rid of. And then here we borrow. There's going to be a lot of borrowing in this one, just because of all the ones. Did that roll over? It did not roll over, okay. Yeah. That doesn't roll over. I should have spotted that. So anyway, yes, we do that. Next bit, we get rid of. Next bit, we borrow, get rid of, borrow. This one definitely rolls over. So we borrow, and then we borrow to our heart's content. And we, yes, this is also, we do that. For this one, we have to borrow again. For this one, we've got to borrow again. We've got to get rid of that comma. And we, yeah, and then we, yeah. Yeah, okay, I was just like double checking that worked, okay. And then this rolls over. So that, get rid of. For this one, we have to borrow, and this one we get rid of. Next, what we do, we keep going like this. We just keep going, like no stopping to chat. We're in the thick of it now. We're in what you might call the weeds. Not to be confused with something else, but we're in the weeds. Why did I say that? That's not... Never mind. That didn't happen. It's not that it didn't happen, but that's not important, you know? Anyway, things just come to me, and then they happen. I'm what you might call someone who predicts the future. Except that's what you might call... I'm so tired of this. Like, I can't... I've just been talking constantly just to fill the void of the space that is being left by me just calculating binary fractions. Like, it's not... I'm not even, like, doing... Like, thinking through any of this. It's just happening with my fingers. Kid named Finger. I'm a finger. Finger would not say that, because Finger is not, in fact, a finger like you might think. Finger is a person who just happens to be named Finger. We messed up. We messed up, actually. This should not have been allowed. Yes, so we are now at 3. And we do a nice little quaint rundown. Just a little nugget going down the stream until it reaches the end. At which point, we had 1. Because that's a big borrow. You know? It's that simple. What is, I'll just mark in the 1s and 0s separately because they're on opposite sides of the keyboard. Little 2-pass little thing. Da-da-do. Da-da-da-da-da-do. Wow-wow. Wow-wow. So, I went, okay. I was just, thought there was, never mind. Yes, so this is our number again. Rep that. That's 147th. Look at the speed and efficiency at which we're doing this. This only took me an hour. Like, granted, there was some... there was some... I lost my train of thought, but yeah, we're gonna keep cranking these out again. This is how we're working. We're just working, cranking the crank until we don't want to crank the crank anymore. And we still want to crank the crank, you know? So, I am driving myself insane. That was me boomeranging insane, by the way. 48, that's 24. 24. Ooh, we're ooh, it gets longer. It gets longer. The chain of 0 gets longer. It's 4 zeros now. We haven't hit that before. And this will be the chain that hits it because it's the, you know, because this is the first one. Now we have 149th. 149th, we add 2 to this. To add 2 to this, that rolls over all the way into that column. We're at 49. I might have to stop at 64 today. Or I might have to stop somewhere after 64. We don't know yet. Because we can't see the future. The future's there for us to see, though. When it comes. When the future wants us to see it, it'll be like, hey. But the future doesn't. The future never comes, actually. Because it just happens that future approaches now. It becomes that, what we call the future at one point becomes the now at a different point. Anyway, that's not important right now. Because we're in right now. And right, yes. So, see? See, that's how that works. And we keep bit shifting, and then at this point, that doesn't roll over. Does this roll over? Maybe that's how I fill the dead air, but that comes with me just calculating. Like, this is just me constantly calculating magic sequences at this point. There's no fun stuff anymore. So, yeah, we do that, and then we do that, and then we do that. Oh my gosh. I still think about that little dot that I keep inserting. It just, I make that longer than it needs to be, and it bugs me. But yeah, that doesn't roll over yet. Sorry about clearing my throat. My throat just sometimes clears itself. Yep. So then we got that. This stream is turning out way better than I ever could have hoped, you know? I was thinking, like, I wasn't sure if I wanted to do it. I haven't streamed in, like, a year, but then it turned out great. Because, like, you know... Oh, we hit 1, we hit 1, we hit 1, we hit 1! Because, like, the thing is, I would have done this by myself anyway. I calculated up to 136, yesterday. all just by myself. It's just like you guys aren't here. Like, you're just watching me. You're just passive observers. But like I don't know what I'm trying to say here. Yeah, so that's 149th. 150th now. 150th is twice 120 is 125th. 125th looks like this. So that's 0.0 rep that. And we just keep going. I think okay, it says 0 concurrent viewers now. We're in the weird place now where nobody's watching. Nobody can see my things here. I could say anything I want, and no one will see unless they're watching the stream replay. But that hasn't happened yet. Like I said, the future doesn't exist. But we, right now, in our now, because the now is the only thing that matters right now, is we have to keep calculating these binary fractions. We're at 50. We're getting pretty close to that 64 milestone that I so scrumptiously. So we gotta, we do the thing. We do the ones. All the interesting stuff is gone now. This is just pure, like, hell, but not hell. It's heck, because it's not as strong. 2 steps in 1. We're at 1. What the heck? We're at 1. We're at 1. We're at 1. So, I have to, like, replay that. Make sure that, like, we did 1 rollover. We did 1 rollover. Okay. We did 1 rollover. You can't make this up. Except you can. But I won't want to make things up. Because I'm not a liar. Right, so we do that. We hit 1. Like, definitely. Because, you know, that's just how it works. So this is our number. This is 151th. And what you might call binary. That is pretty nice. This is like actually kind of a best case for us at this point. Well, actually, yeah, because like we have these zeros anyway. The part that really matters is this. Wyatt? Well, yeah. I'm just realizing why. Yes, of course. Yes, right. I guess I should just say the thing I was thinking about. It was I was thinking, how come it has to include all these lead zeros? Because like you could think of it as like, it's because you need all those lead zeros because it's small. But like, does the repeating part really have to include those lead zeros? But then I realized, yes, of course they do, because it's not because then it's the same reason these are here because it's not a multiple of anything smaller. If it were a multiple of something smaller, you could put those lead zeros there, but there are no lead zeros because it's not even. It's not a multiple of the power of 2. That's why that's there. Nobody's watching. Definitely nobody's watching right now. This is really cool. I'm in like the solace, the nobody watching of the desert. The desert can be a not nice place if you don't like the desert. I don't know if I like the desert because I haven't been there, so I cannot comment on this matter. So now because we have 150 tooth, if you have 50 tooth, then you need to see a dentist because that's not normal. That's a joke I made earlier, and I recycled it. And because I said it again, it's not that funny. Anyway, 150 tooth. If you have 150 teeth, you are a shark. 25, 26. We are at 26 right now. We take 26. We take 26. Put another 0. And we move on to the next match. I need to take a second. Like, actually, this is driving me insane. I can't just keep continuously talking. I'm at... Is this why I don't stream? Is this why I don't stream? Because anyway. Also because, like, there's never an active chat. Oh, we have a one concurrent viewer now. All right, that's cool. Anyway, yes, I'm calming down. Are we ready to do 153rd? I think I am. We are approaching 64. I'm considering ending at 64 for my sanity, but I think I could push it to 128. I just think it would be really funny if this was like a 4-hour stream. I could continue into midnight if I wanted to, and I think I might want to. It just depends on when I feel like stopping. So anyway, I've said that before in this stream. I just wanted to reiterate, in case the person who is... Anyway, whatever. I'm not doing this for anyone but myself. That's my core thing here is I'm not doing this for anyone but myself. I don't care about pleasing anyone watching. I'm just doing this for myself. Right. I need to stop saying the same thing again. The same thing again. I broke my rule. Oh, we didn't roll over. What? Yes, okay. Does that look right? Whenever it generates a sequence of 1, I'm like hesitant. Like, is that really... Does it really generate a sequence of 1s? That was like a big reset there. I was too into talking, and then... Well, I need to redo that. So it's that, get rid of. Now we have 3 1s. We just bit shifted a little bit. We're at 3. We got a little small nugget. Look at that. We went to 4 to 3 to 1. Look at that. Look at that. That is a little marvel. It would be really funny if at the end of this 3 chain it went back into the normal 1 chain. That would be extremely funny. And I really want that to happen, but I have a suspicion that it won't. Because like, when we get to this point, actually no, we're not at that point yet. This is not one more than this. It can't be. And it is not to be. Because, yeah, then we do these. It'd be funny. But the 1 will have to wait. It is there, but yes. Fun has its limits. Oop. Have we seen this before? We have not. We may continue. Didn't roll over. Still continues to be a problem for me. Ooh. Okay, we're not there. We get the other fun case where hello, person who says they have no idea what this is. If you want to know what I'm doing, then you can watch the start of the stream. I'm calculating fractions in binary. Like, you know how, like, 1/3 is 0.333 in decimal? Like 3 reoccurring. I write that as R3. Like, if it's 0 R3, we're just marking the recurrent point instead of writing an overline. It's just a notational thing. That I'm just doing that, but in the binary numeral system. Right. Well, I forgot where I was. Yes. Okay. I was about to start this one. So we borrow, and I'm doing that partially by doing magic sequences. Again, the start of the stream explains it pretty well. If you would like to know what is going on here. I'm just looking at the graph. I keep on going in and out of like having like 3 viewers and having like 1 viewer. It's fun, just like hear little sparks of people wanting to see what's up, and then it's not very interesting. I mean, to them, because they're not the ones doing that. I said that at the start. Like, it's only interesting if you're the one doing it. It's only fun if you're doing. It's not fun to watch someone do this, but I'm doing it anyway because it's mildly funny to me. Not like haha funny, but just it's like respect for a bit funny, you know? I don't know if that makes any sense. I don't think it does. Oh yeah, okay. I was just like double checking my stuff there. And then we hold on. Yes, we canceled that. Right. Just doing a little modulo calculation. I love modulo calculations. What's wrong? Bracely said that in BFB, but it's actually a slowly modified quote for the circumstance. Oh, and also this is just binary right here. It's using dots and pipes in place of 0 and 1, just as a notational thing. It's not that hard. What was I doing? That does not roll over. Ooh, ooh, ooh. We hit the one we missed. This, I think, has the potential to be funnier. Like, we're hitting all of the sequences of all ones. That is beautiful to me. That is beautiful to me that this is one of the magic sequences. See, I wouldn't have discovered this if I just looked up all of the magic sequences or all of them. I'm calculating myself, and it's fun and beautiful because I get to discover everything as I go along. We haven't seen this before, have we? We have not seen it before. I just want to double check because if we've seen it before, that means I made a mistake. And that we didn't roll over. That was so easy. I just messed up. All right, we passed the dip. It says there are no concurrent viewers. That's it's fun. It's fun. Actually, it says there's one concurrent viewer in one place and 0 in another. So I don't know it's true. And I don't need to know it's true because I don't know. It's just yeah. I'm broadcasting myself. This isn't just yeah, I'm just broadcasting myself. I can't this isn't real interaction or anything. Oh, hold on. Oh, is this hold on. Where are we? Oh? No, because that's our 1. We hit 1. And look at that. Look at all of that. That is beautiful. Okay, so first we have the little chain of 1. And then we have the chain of 4. Then 3. Then 2. And then the big one that only lasts for 1. But it's just the fact that we hit them all. It's beautiful. It's a fun coincidence. It's a fun coincidence that I enjoy. I enjoy fun little things like this. This is a long one. I think this is one of the longest ones we've done. Is it the longest one we've done? We'll have to find out when we copy this whole thing. Paste it here. My computer fans are going. I can just try unplugging. There we go. I think that should mitigate that. Yeah, that was super long. That was a journey, and I loved it. That was amazing. Look at this. We did this. Sorry. I did this. You guys are watching me do this. That is how this dynamic works. 54. We are now 10 away from the actually okay, we're only around 4 magic sequence calculations away from 64, which is a really good stopping point. Yeah. We have 2 concurrents again. I'm just popping back into this thing every once in a while. Right, but yes, 54, we got to stay focused and figure out what half of a 54 is in decimal. And which is hard because I'm really bad at mental math and decimal. And converting it to binary and doing long division is a process. I tried it once for one of these, but it was let's not go into that. So 54 divide by 2. Right, hold on. We were around 20. We were on 26. Was it 27? 7 plus 7 is 14. Yes, it was 27. So we have 0.0 That's 54. Next we have 55. Yes, another magic sequence. Here we go. Flip the 2-bit. We go again. So we do a big one of these. Yep, and then we do a big borrow, of which these two are 1. Sorry, 0. And then here, it's yeah, that works out. Wait, we flipped that. I think I just tried to borrow when I couldn't borrow. That's funny. But only mildly funny. Some things are only mildly funny. Like, that's something I've realized recently, is like, yeah, it's like that famous and verb joke, like, her name is funny, but not haha funny. Oh, that's fun. That's real fun, actually. Hold on. I've got to, like, double check myself. That's too fun to be real, right? We do that. We do that. We do another one. We cancel. That is... God, I love binary. I know, like... Yeah, math can be beautiful. If it wants to be. You know what? Even that, like, well... Yeah, even that... I'm not even gonna talk about that. Even... Ooh. We reached the end. Hold on. I need to, like... this might actually be a good opportunity to, like, make sure that... Because, like... Yeah. Yeah. Okay. Right, anyway. We got there. We totally got there. Because this is one less than that. Yes, obviously. One more, sorry. All right. That's a nice little quaint one. Nice little nugget. Quaint little nugget. We are gonna make it to 64. It's gonna be an adventure. I might go to... I'm not even gonna talk about how far I'm gonna go at this point. I'm just gonna keep going, because that's more important to me. 56. Where were we at before? We were at 27. Then we go to 28, right? 28? Yeah. And then we add another 0 to 28. It's real fun. And, like, all of these are evens of evens. Yeah, evens of evens. I think that's a good way of putting it. Like, there's probably a more technical way of putting it, but there's just that. Okay, side tangent. The ones where you have multiple zeros are evens of evens, where they're multiples not just of 1, but of 2. Sorry, not just of 2, but of 4, or they're... An even number can be expressed as 2n, where n is an integer. So for something like 54 here, if you have 54, you get 17. Wherever 17 is 27, actually. So you have it, you get 27. And you can see that, like, it's just recurring from the point. That means that if you can't just, like, multiply this by 2 and you'll get... It shows that 27 is odd. So it's the end of the road. For 56, you see those zeros mean that if you take 56, have it, you get to 28, which has 2 zeros at the start of it. So when you have 28, you get to 14, which when you have it, you get to 7, which is odd. Not necessarily prime, just odd. And that's, yeah. So they're the evens of evens, the ones with multiple zeros. And it just shows how many layers you go deep. It's fun. Like, you go to 48 here. 48 is part of the longest chain that starts at 3, the first odd number. The second odd number. So anyway, what were we doing? We were doing 57. 157th. We flip our 2 bits. We put all ones, and we get rid of these ones, because those ones are different from ones because they're 0. Then we're going to butt up against the ceiling again, which means we go down by 1, I think. Because like, this is 1 away from this. So we butt up against the ceiling, we go down by 1. I could just subtract. Like, I think it's fun to just do the same process for each one. I think also just like mentally easier. And I feel more confident in doing this. Yeah, see that? Like it, because we go down by 1. Yes, because yes, I can see that. And then we go down by 2. It's a fun pattern that always arises. See, we go down by 2, and then we go down by 4. This bit should just flip. So, well, yeah, first we have to do the bit shift. And then that cancels out, and then those 2 get borrowed over. Ba-boing, ba-boingle, and 3. Ba-boing, ba-boingle, and 3. It's so fun. So fun. What happened there? That was not, it shouldn't have happened like that. Okay, let's try that again. We borrow it over. We do that borrow. Okay. And then we would start really picking up steam and start getting into chaos land. The calculation of these magic sequences is just so fun, just like seeing the ways that it just bounces around. I want to make a visualization of this, I think that'll be my next step, is like, once I finish this stream, I have schoolwork to do, but like, I'll find time in the middle of there to appreciate beauty in the real world. And I'll make a little bit of code that, like, the way I want to visualize it is like, each number as it points around a circle, and then the doubling in modulo just like bouncing around, and it's wonderful and beautiful. And we keep going. We have to keep going because it's the rules, and if you break the rules, well, there are no consequences because they're my rules, and I'm allowed to break my rules if I feel so. Yeah. We keep going, and we hit 1. I'm gonna, yep, I can just write 1 there. I make my own rules. 1 1 1 0 1 1 1 1 1 0 0 0 0. No, that's a 1. And that looks like, yeah, that's just a perfect compliance to Midy's theorem. Or I shouldn't say perfect, like, compliance to Midy's theorem, because I don't know the details of Midy's theorem, but oh, that's the tab. But as like a simple case of Midy's theorem is the way I should word it. One sec. And let's rep that. All right, another even number, another easy one. 58 is, where's 58? 58 is 58 is twice 29, right? So that's 0.0 rep. At this point, I haven't been saying them, but I'll say this one. Rep it 0.0 rep 0.00001100101001111 0.111 Haha. So we keep going. Another one. 59. A 59th. I can taste 64. I can taste 64. We flip the 2-bit. Look at that. We're so close. We have 2 more magic sequences to do. Actually, I think only 1. So no more time for chit chat. We go, we go, we go. This one's gonna have a slow start. Just getting up to speed. I really want to know how magic sequences work, actually. I think maybe the like the mini paper in the Better Way to Count like GitHub shows that. I should read that. I don't know. It's just every time I revisit the Best Way to Count, it's always an experience. It's like this is what I live for. Ba-ba-da, ba-da. Then we borrow, and then we do, we do, and then we do a bit shift. I don't know if you can hear my keyboard sounds. It'd be cool if you can. It's fine if you can't. That did not roll over. It's like sometimes it takes me up until like the final bit to realize that it doesn't roll over. It's funny. It's not like, yeah, it's just funny. It's not like frustrating or anything. It's just funny. Sometimes you just gotta laugh at yourself, you know? We haven't countered that, so I've been getting really good at like not like it started a bit rocky, but now I've really gotten the hang of this. It's like just I really just do it automatically. It's real fun. I think you should try this sometime. Maybe start at an offset so you don't like just redo what I've done, or maybe you do want to redo what I've done. It's fun to rederive things for yourself sometimes. Or maybe you don't want to do this. That's okay too. You're allowed to do whatever things bring you joy. These are my thoughts on life. Yes, yeah, those two just get borrowed over, and then we do a big borrow. And then... Really? Yeah. Yeah, that gets cancelled too. It's always also fun because like you never know when you like there's mystery to it. You never know. That did not roll over. You never know when you're gonna hit one, and it always comes as a surprise to me. You always like come in through the back door. It's I just love doing this. It feels good to do. We hit. We're bonking against the ceiling. Yeah, we borrow from there, borrow from there, borrow from there. Then we. It's magical. That's why they call it the magic sequence. It's just magical every time. It's a magical experience. And I'm sharing that magic with everyone. If this isn't magical to you, then that's fine. I'm entranced at this point. It just like I can't stop. It's I'm in too deep. I've got to keep going, and it's just like, why do I keep going? It's for the sake of going. It's I've got too much momentum, is what it is. It's like I can't just stop. Okay, that has to be wrong. Oh wait, hold on. What? What the heck? No. Hold on. What happened is we hit 0. So let me recalculate and make sure that we didn't actually. Yeah, because those carry over. That carries. Dot to dot. Yes. Okay. Okay. I missed one. That's what happened. Oh yeah, this rolls over. It's a subtle rollover, but you should be able to spot it if you have a good eye for this. Okay, what am I doing? What? How did that shouldn't have happened? Because we didn't roll over. Sorry. Don't listen to me. I don't have a very good track record with this. That's like one of the first false positives I've gotten. Interesting. Right, yeah, we get rid of that, and then the final one. Woo! Oh, we hit 100 lines. That's actually normal. We just like, it's just because we have a long magic suit. Ooh, this is another long one. I wonder how. This one's gonna be long. This is gonna be a fun long one. All right, it is 10 p.m. right now. We've been going for like 1 hour 45 minutes. I could go until midnight. Like, I'm serious. I could go until midnight if I want to, and I'm still not sure if I want to. I don't know if I'll continue past 64. Okay, right. Let's get back to it. Yeah, so we shift it, borrow, mini borrow, and then normal stuff. Oh, I think we're recovering from another like near ceiling hit. Right, so we shift it, borrow, and then oh, oopsie, oops, full. I think we got trapped in a loop, and that means I made a mistake. Let's check with this subtraction in particular. I did kind of like I slowed down there. That makes sense. Right. So we borrow from there. Hold on. Oh. Okay. We've seen this number before. We can probably find our loop point by yes. So the problem was here. Yeah. Borrow. And then we borrow. Okay. Alright. I've been really good at catching mistakes here. Like, there's still a chance that I've missed something in one of my calculations that I haven't caught yet. And that it still got back to 1, but I don't know. It's just part of doing this by hand. I could, if I really wanted accurate results here, I could like do this twice. And if I really wanted accurate results, I would just use a calculator, write code to do it. But I'm doing this by hand because I like doing it by hand. I like the process of doing it by hand. I love like the mechanical nature of just like cranking through a process. What I'm not aiming for here is accuracy. I'm just aiming to have fun doing all these. So, I'm just realizing every one of these, like that starts with R, is just comes from a subtraction, which I just realized that I find that lovely. Right, but we're still doing this. We're not at the end of this one yet. Riveting gameplay here. So, oops. I calculated that one fully, right? Yeah, I got to the beginning. Yeah, so we bit shift it. I am losing my voice a little bit. If you go back to the beginning, my voice did not sound like this. Roll over. Dip. Boop. Boop. Baba. Boop. We're gonna hit one eventually. There are only so many numbers we can hit. And if we hit all 50 of them... Oh, right, Oops. I think... Yeah. It'll be that, I'm pretty sure. Because if I do that, then we get both of those. So, yes. Keep going. We haven't hit this before. We're okay. We're good to go. Good to keep going. How many ones in this format have we hit? Like where it's separated like that? Because I know we've hit another one of those. Like at least one, right? Have we not? Oh yeah. Ooh! Ooh, that's fun. We hit like one of those, then the broken up by one. So we're going to name these by their gap. So we hit the 1 gap. And did we hit the 2 gap? Oh, we're on the 2 gap. Oh, we hit the 3 gap. We might have hit the 4 gap already. I can look for that myself if I want to. And I'm pretty sure the 4 gap like disintegrates instantly, so it could be anywhere near. This might be a case like that other real fun one that we hit. Ooh, no, like see, there's that's the reason I'm doing this by hand. It's because it's just fun. Right. So, to me at least, it's again like different people have different ideas of fun. Yeah. Okay, rolls over. That's what I say when I roll over. I say it in that specific way. Oh, we're getting tight. Okay, that's close. What the heck? Oh, no. Oh, we hit 3. It just keeps going. It seriously just keeps going. And then at the end here, oops, we do a borrow from there, and then get rid of these ones. Oh, we're right here. Yeah. Oh my gosh. Are we gonna hit all of them? Are we gonna hit all 59? I think we might. Or I think we might get close, because, like... Yeah, we're approaching 120 lines here. We're gonna hit this soon. Like, there's no way that we don't hit this soon. Okay. And then... Right? Right, when is this gonna end? Like, there are only so many numbers you can do. That's it! I think we hit it. Is that it? Right? Oh my gosh. That... Wow. Because, okay, for completeness... Yes, I do have to... Hold on, no. Because this overflows. That's that, and that. Oh... It's brilliant. It's brilliant. I'm gonna do this the other way of just numbering the ones. I might end at 64. I think continuing. It's just such a good note to end on, you know. As much as I want to stay up till on. I don't know. I'm still weighing my options. I could continue back to. I might even do a part 2 stream, but yeah. Again, I'm only doing this for myself, and it's all based on what I feel. we've got, oh, just look at all that. That's our longest one yet, and look at it. Look at it in all its glory. We calculated every single bit of this. Look at it. It towers over its surroundings. Hold on, I haven't been reading chat. What's this new message? I found it, hold on. I never thought anything could beat that, but I was wrong. Well, thank you for enjoying this. I didn't make it to be enjoyable. Well, I didn't make it to be enjoyable to anyone but myself, but I'm glad that you are enjoying it. I don't know if you're still watching because I haven't been reading chat, but yes, thank you. So number 60 now. 60 is twice 30. So we do that. 1 over 61. Oh, that's going to be another one, isn't it? Oh. We're going to have to do one more magic sequence. We're going to have to do one more magic sequence before 64. And so let's just get that one over with. Then we'll get the easy ones because they're around a power of 2, and if it's near to a power of 2, it's easy to get the fraction. As you have seen, it's been a while since our last power of 2. It's actually been since 32 was our last power of 2. Whew. Yep. I'm still not sure if I want to go for like 4 hours. I'm not talking about that anymore. We're just calculating. So, right, we do the big one, and then we get rid of these. So we start at 3, and then our 3 continues down the line. And until it reaches here, at which point we must borrow. We borrow all of its things, and we borrow again. The funny thing is I don't even, like, hello. Hello, I've read you the most recent message. Oh, yeah. Yeah, this was half, for me, it's not just from the computer science, it's from the mathematical angle that I love binary. It's from the video The Best Way to Count by The Best Way to Count. Sorry, it's not by The Best Way to Count. That's just the name of the channel it's posted on. I need to redo that because I was not paying attention. Yeah, because that I saw that video and it has changed the way I look at the world. I'm only slightly exaggerating there. But it is a beautiful video. It hits all the beats, you know. Oh, that's a long one. Oh, this could, I realize, now fully internalizing, this could take a while. This could take as long as it wants to. How were they before? Like, the lengths of the fractions? Because, like, leading up to a power of 2. Because, okay, here, uh-oh. I'm now realizing they come in spikes. And I think there's a chance 61 could be another long one. So we'll just buckle up and we'll get going. Yeah. Oh yeah, I'm also into linguistics and interested by number systems. Yeah. Binary fractions are easy. You just need to calculate. Well, some of them are really easy, like especially ones like up here where they're like all close to a power of 2. But yeah, they're tricks like so I'm gonna say the tricks again. I said them at the beginning of the stream, but I'll say them again. So for 1/3, for example, it's 1 less than a power of 2. So the way it's written as rep 1 in base 4, because that's the power of 2 that is below. And so again, for like 7, it's rep 1 in base 8 because it's just below 8. And then for ones that are just above, they're rep 0z, z being the largest number in that base. So it's 1/9 is rep 0z in octal. So that's how that works. The rest of them are done using the magic sequence, which is you double it and then you start with 1 and then you keep doubling it, and then if it rolls over your number, you take modulo, and then you keep doing that until you reach 1 again. And that's if you so then between them, when it's decreasing, when it's increasing, it's 0. When it's decreasing, it's 1, which also happens to correspond to the final bit of all of them. Just because it's like when you roll over, you always start with a borrow, and when you're doubling, it's always it always adds a 0 at the end. It's just very beautiful in all the ways it can be. Anyway, I will continue with this magic sequence. Right, so we borrow, big borrow, and then we keep doubling. So that's our number. And then we double it again. Sorry, I'm just still contemplating if I want to continue about 64, but we're not there yet. We've got one more magic sequence to do, and then we're gonna be. Then we're at the whims of whatever. Yeah, the patterns are really fun. Sorry, I have the stream turned to normal latency because I wasn't expecting to be interacting with chat that much. Oh, I'm using Sublime Text as a text editor. It's okay, so it's like free, but it's like in the way that FL Studio is free. And the thing is, it's also fully featured. It's just like you need to buy a license. Except it's still fully functional without a license. It's yeah, I haven't bought a license. I may at some point if I feel like it, but yeah, it's Sublime Text. It's fun. Right. Continuing. Well, where were we? Where were we again? Right, we just did that, and we're doing the first borrow. We do another borrow. Oh, we hit the ceiling. We hit 1 less. You know what that means? It means that the next one, it will decrease by exactly 1. Which looks like... Hold on. That's right? Hold on. Yes, so we borrow... Yeah, and then it's just... We carry those over. Or borrow them over, rather. Carrying goes in the other direction. I should plug in my computer. I'm gonna do that. Okay. Would Notepad ++ be as to Reaper this as Reaper is? I can't remember what the how Reaper is in terms of like licensing or whatever it is. Maybe? Yeah. I think actually it is, I think from my understanding of Reaper, it is like Reaper, where it's just it's not free, but you can get it for free. Yeah, I also compose music. Oh, that should have been evident. Yeah, I've been doing a lot of music. Yeah, this year I released like one album every month for 6 months. I got busy, so I couldn't keep that up. But that's fine, because that was only a rule I set for myself. And I am allowed to break my own rules. Okay, I need to finish what I'm saying before I actually continue. Yeah, so 300 breaks is pretty old at this point. And that's it. The music I do these days is a lot better, and I need to focus. So it's like that, and then we do that, and then right, and then we carry from there, and that makes it different. So yeah, I have 2 albums. Okay, I have 1 album that's pretty much finished. I've just been busy and haven't a lot of the time to like finish the cover, because I want to do the cover in Blender and all that. Super Metroid Music Editor. I'll write that down. Super Metroid Music Editor. Yeah, I'll check that out. In fact, okay, this is gonna be really distracting if I put this in. I'm gonna put this in a new tab. So yeah, thanks. I will check that out. I actually. That's cool. Yeah, I've never actually gotten that much into gaming. It was like a personal choice where I was just like, I didn't want to waste time. Like, I think it like started really early. That I, like as a okay, hold on, no, I did that wrong. Right, so it's that, and then we do that, take away, borrow, borrow. There we go. So we keep going. Yeah. I was kind of the opposite. I did like sporadic music for years before I started doing albums. And then it's just like what got me to start making albums was I made one song that was, it felt like so different from everything else that I ever made before that I wanted to make an album. I was like, because, yeah. And then we double, and we double again, and we are so close. Okay, actually, yeah, this is gonna be a long one, isn't it? Right. Okay. More borrowing. And then, hold on. Right, yes, so we borrow. Next column, we borrow, and get rid of. But I did them in the both simultaneously. Okay. Ooh, we hit one. Because, yep. We hit 1, yes. I think this was actually slightly shorter than the last one. Yeah, because the last one went up to like 120. So yeah, it's fun. Like, there are patterns in the lengths of these, but they're not consistent. It's like prime numbers, you know? Okay, because these are so closely related to divisibility that you know, yeah. And it's there. Okay. Let's make this big long number like that. Rep that. Oh, there we go. We're at the home stretch. 63. Sorry, not 63 yet. 62. What is half of 62? That's 31, right? So 31 is this. Oops. So we 0.0 rep 00001. And now 1/63. Now we get to use our fun tricks because we know how these work. Yes, they are. Yes. Patterns where? Here or in the magic sequence generation or in here. Yeah, they are neat patterns in both. Right, 63. It's rep 0. Hold on. It's rep 1. Hold on. Yeah. It's rep 1 in base 64. So, hold on. 64. Okay. 1, 2. Okay, this is 4. This is 256. 64 is right here. In base 64, this is 1 digit. 1/63 is that. 1/64 is point that. Now the question is, do we want to keep going? Because I have been at this for 2 hours straight. I would be willing to be up for another 2 hours. The thing is, they're gonna get longer, and so it's not actually gonna be 2 hours. It's gonna be longer than that. I think I might just keep going for a little bit, and then I won't end at a power of 2. Things don't always end at clean, nice numbers. And I would always, like, if I go to a power of 2, you've got to do the next one, That's got to be, like, rep that. Hold on. And then 1, 2, 3, 4, 5, 6. You've got to do 65th, right? So then, and, you got to do 166. Like, it's an even number. It's easy. Which is, twice 33, so that's... Oh, yeah, it's also fun how it's, around powers of 2, you not only do you get these easy ones, but you also get the ones, the even numbers around them that are of the things from the previous power of 2. So that's 66, and then and then you think, oh yeah, maybe I could go for another one of these magic sequence ones. So then you flip the 2. Actually, no, you don't just flip the 2. Okay. We have added a whole new bit to our calculations. So hold on. We actually have to make this slightly wider. And in fact, we have to add to our initial stack one of those. So, right, so it's 64, and then, so we have 65, 66, 67. Yeah. So that's 67. Do we do it? All right. All right, we're doing it. We're gonna keep going. I don't know for how long. I don't think we're gonna make it all the way to 128. I'm pretty sure we're not gonna make it all the way to 128, but we are gonna keep going. Like, we've got too much momentum. Like, okay, like, we just hit the peak right there at 64. You don't end right at the peak. You gotta like settle it down. You gotta like trail it out. Look at the thing on the side here. Like, hold on, can you see that? Yeah, I can. Oh, I think is the stream like glitching out or something when I leave to the other thing? Is it working right now? Is it? Oh, it's like low bitrate or whatever. Maybe my internet's being bad. I'm gonna like talk here for a bit until the stream. Okay, or maybe it's. I don't know how the stream quality is right now. Oops. I don't know. Okay, are we good? Are we good? Okay, yeah. So we're just at a lower bitrate. That's fine. We're just streaming plain text here. Like, who needs high bitrate for plain text anyway? Oh, we're back. We're back. Okay. I just like saw my stream performance drop, so I wanted to like pad that out for a bit. Anyway, yes. We're back to magic sequences. We keep going. Should I pop out the chat so I like have it so I don't have to like keep going over here? I think maybe I should do that. What does this do? How do I pop out the chat? Do I have to like open the stream or something? Let me go try opening the stream in another tab. Yeah, sorry. Stream things are happening right now. We're in the middle. Like, this is like the main program is over at this point. We're just keeping going for the heck of it, if you will. Can I pop out chat from the main stream view? Can I pop out chat from the mainstream view? Please tell me. Please load first. Please load. Please load. Please load. Please load. Are you gonna load? Is there an option to pop out the chat? There it is. Okay. Alright, cool. Now I can just like... I don't know if this is going to look weird or anything, but I'm going to move this over to my other desktop. Yay, I can look at chat now. I can look at chat while I do my calculations. That's going to be fun. Anyway, right. So we're getting back to the grind right now. Back to the my gosh. Okay. I might end it soon. I'm getting tired. Like, not like sleepy tired, but exhausted from all this. But it'll be fine, you know. All right, so yes, we keep going. No second guessing myself. We're going. Off we go. Like a herd of turtles. Yeah. Ooh, it got shorter. And then we do it again. Hold on. Hold on. What happened in that previous one? Did I do that correctly? Yes, I did it correctly. Okay. I saw those two ones next to each other. I wanted to make sure that I wasn't a mistake on my part. I don't know. Let me check how many. Whatever. Let me find the. Yeah. Okay. Oh heck! Is it? It says it's not. Okay. Stream performance is doing it. I actually don't know what this looks like on your guys' end, or your person and. Oh wait, hold on. I have two concurrents now. I thought I only had one. Okay. I'm gonna stop looking at that. I'm just gonna. Right. This is the grind right now. This is what you might call the grind. You know, you know what they say, you just gotta like keep that grind on. You gotta keep going. I don't know what I'm saying. I do though. I'm saying many things. I'm saying many thoughtful things. You're all writing these things down because these will be on the test. Just shifting those over because that's how this works. I don't have the confidence to just like do things like shift them over. Like when I see this, I'm just like, oh, I have to do each one of these individually, even though I know that. Ooh, 3. We hit 3. It's a fun little chain. Fun little chain. Nope, nothing went wrong. Now we do a big one. And we... Ooh! Oh! I see. That's how that works. Is that still larger? No, because we also get rid of that. So we do that, and that, and that. This is a fun one to work through because it's like just above a power of 2. It's just, yeah, it's the way bits work, the way the bits decide to happen. So those just come over, but we can't do that because we didn't roll over. Yes, so we do that. Do a big borrow. Get rid. This might be my last one, to be honest. I was thinking, oh, I'm gonna continue on, like maybe like up into like what the 90s, but it's not gonna happen. I'm petering out like right after this, and I don't even know who Peter is. What? No, wait, hold on. What am I doing? What was I trying to do? Wait, was I seriously just absent-mindedly doing borrowing on before we even rolled over? Wow. And it took me like oh my gosh, that is it. This is a big sign that I need to stop, is when I'm making mistakes like that. I popped out chat, but the chat is like inactive. I should have popped it out like while there was active stuff going on there. Okay. We have excellent connection again. We're good. We're good. Right, and then... Yeah, this is our last one. It's been fun, but I can't keep going like this. Oh my gosh, I did it again. I might have to redo this one next time. I'm not okay. I don't even know if there will be next time. I'm not making any promises. What? Oh my gosh, I need to. I did it again. I might. Maybe it's just because the numbers are getting like longer that. Maybe I don't know. I'm tired. Oh my gosh, we hit one. Nice, very nice. Yep, that's it for today. Yeah, 2 hours is long. Like, I like repetitive tasks like this. One time I wrote down file names from a live stream for 6 hours straight without stopping, which was too long. Too long to be doing that. I don't know why. I guess I was fine the whole way through. This is exhausting for me a little bit. I think more because I'm just like continually on right now because I'm live streaming it. I wasn't live streaming that. Hold on. I can check this for Midi's theorem. Or I can't. What the heck? Why? It looks weird. This one looks weird. Why does it look weird? I'm very curious about that. Let's do one more, you know, just for the sake of it. Let's do one 68th, because even numbers are easy. You just reuse your old work. 68, that is twice 34. 34 is this. Ooh. And I think that's a reasonably good note to end on. We got an even of an even. We got an even of an even. It's a multiple of 4. And that's it. I'll leave the spot open for next time. I'll leave my work for the previous magic sequence. And that'll be it.